This is the qualifying examination for applicant for the Japanese government Monbukagasho scholarship MEXT and physics college of technology students, and please note that the test period is only 60 minutes and it is 2006. Okay, let's start. Problem 1. There is an object which has mass 10 kg. Its starting point is origins. It's moved in the velocity 49 meter over the second on the round surface, and it's come to stop here. So this is the directions of its ways that we can write as this, and this is the directions of the normal force. So normal force is always vertical to the surface of the object. So it's ends. So why we need to know this? We need to find the kinetic friction force. So kinetic friction force is equal to the coefficients of the kinetic frictions multiplied by normal force. And as you can see that the normal force is opposites to its base, that equal mg. So that's why n it's equal mg here. So we plug all the informations. The values of the coefficients is given in the problem. It's 0.5 and in mass and the gravity, so 49 Newton. Number 2, find the time which the objects take until it stops. So this object is moved on the round surface, so its speed is decreasing, so it will move slowly than before until it stops here because it experiences frictions. And as you can see, the directions of the frictions, it opposites the motions of the object. So we have the formula. Final velocity, it's equal initial velocity plus acceleration multiplied by t. It's for the every object that has acceleration, it accelerates or it decelerates, and we find the t. So we have here, and as you know that this object is experience the friction force that opposite it. So according to the second laws of the Newton, we have minus F that equal ma. Yes, and its value is minus 49 that is calculated here, and it mass 10 a. So its acceleration is minus 4.9 meter over the second square. So it means that in 1 minute its speed is decreased by 4.9 meter over the second. So we plug all the information. The final velocity, so it stops here, so it's 0 minus 49 is the initial velocity divided by its acceleration, so it's 10 seconds. Question number 3, find the amounts of the heat which the object lost, and it lost 70% of its mechanical energy. So the reason why its velocity is decreasing because it's lost its energy. So we have to find that amount of the hits. So the first thing is to find the mechanical energy. So since it's on the surface, so it has no potential energy. So the only energy that it has is kinetic energy, that equal to the 1/2 mass multiplied by v square. So we plug the information here. So we have 12,005 joule. So it is initial kinetic energy that we have it here. So its amount of heat is lost 70% of the mechanical energy. So we can say Q is the heat that's object losses. So equals 70% multiplied by the mechanical energy. So it's 0.7 amp. So we multiply it, so we have 8,403.5 joule. But it is in joule, but in the problem we are about to find it in calorie. So we need to know that 1 joule is equal 4.2 calories. So in order to convert joule to calorie, we divide it it's by 4.2. So here's 1 joule is 1 over 4.2 calorie. So we divide here with here, so we have 2000.83 calorie. And as we write in the paper, we need to write 2.0 multiplied by 10 to the powers of 3 calories. Two significant fixture. Problem 2. We have an object which slides on the surface of the inclined plane, and this plane it has a right angle is theta. First of all, we would like to find all the force that acts on the object when it's slide here. So the first one is the weight base, the object base, that's its direction is always downwards and it vertical to the surface of the plane here. And we draw this to represent the force that has on the objects to pull it to downward here, and we draw a right triangle. So this angle and this angle it's equal to each other based on the triangle theorem. So this is the hypotenuse, the mg, and this is the opposites. So the opposites is mg multiplied by sine theta. So the first question we are about to find the accelerations of the objects here. So how it accelerates. So according to the second laws of the Newton, uh, the sums of the force that acts on an object equal to its mass multiplied by its accelerations. And the only force that acts on the objects on the x-axis here only mg sine theta, and its speed its acceleration is a. So we cancel m, so we have its acceleration equal gravity multiplied by sine theta. Second, find the accelerations of the objects again, but this time uh, they move these planes in uh, to the right. They move all the planes to the right. So here they move the plants. So when they move the plants, there are more force that can happen on the objects. So here, uh, the force that's the results of that uh, movement is minus ma, because it's moved in the a acceleration. So this object is uh, experience the opposite force is minus ma, and this data is the same, so that's why this is the adjacent. So the adjacent which has the hypotenuse ma, so it's minus ma cosine theta. And at that time the problem said it's come to rest. So when it falls down here and upward here are the same, so it come to rest. So according to the first law of the Newton, when an object is in rest, so all the force that act on it is equal 0. And what are the force? So the force down here, the mg sine theta, and the upward here, it opposites. That's why it has a negative sign, ma cosine theta. Here opposites. Here is for 0. We study only the x-axis. So we cancel m here and we find a here. So it's it will move it's here and cancel m. We takes the cosines to the bottom, so it become a equal gravity sines over cosine. So sine over cosine, it become tangents theta. So a is equal g tangent theta. This is the end of the video. Thank you and see you part 2.